Okay, hello everyone. Thank you so much for joining me today. My name is Francesca Lazzari, and today during this session we're going to learn together how you can build machine learning models on Azure faster than you think. So this is a topic that it's very, very important for me because I started my career at Microsoft as a data scientist probably about 6 years ago. And in this data science team, I was building hand-to-hand machine learning solution for external customers. And I was working with developers, business analysts, data experts, visualizations experts. And all these people, we were all with different technical background, but thanks to this tool that I'm going to use today, we were able really to work together. It's really a tool, and I'm referring to Azure Machine Learning Designer, that is able to unify teams where you have to build machine learning solutions, but you have also to work with different people with different technical backgrounds. We are going to use also Visual Studio Code for the data preparation because actually the entire presentation is based on, or at least inspired by a real customer engagement I worked on about a year ago. So some of the resources that I'm going to use, if you're interested in learning more about these presentation slides, you can find everything at aka.ms/AIML30. If you want to see the code that I built for you, is in our GitHub AIML30 repo. And then all the resources for all these amazing developer guide to AI. We saw Seth, David presenting other two presentations, but then we have other two after these are going to be at aka.ms/myMSignite, the tour. So what we're going to learn together today. First of all, what is machine learning? Because I think many of you know a lot about it, but most of my customers, actually, the first question that they ask is, what is machine learning? And most importantly, when machine learning is the right tool to solve my business problem, to answer my question. Then we're going to see what are the different machine learning tools on Azure that you can use, how you can build a machine learning model with no code using the Azure Machine Learning Designer. And finally, of course, like in every end-to-end machine learning solution, you want to test and then deploy, operationalize your model. And we're going to use our app in Visual Studio Code to consume and get the results from our machine learning model. So this customer is a very interesting customer because they are a big retailer, Tailwind Traders, and they came to me with a business problem. And they were like, okay, we don't know how to optimize our inventory. They realized that over the years, they were using one sales forecasting solution for all their stores in different locations and also their products. So they realized that they were having some stores in Europe with there were a lot of tools and products that were not sold at the end of the week, and there were other products, other stores in the United States that actually they were left without products. So basically they were not able to predict demand in a very accurate way. So they also asked me, but is machine learning something that we can do? Is machine learning something that with our data we can use to solve this optimization problem? So what I did, I wrote an article for them. Actually, they inspired me because they were keeping asking me this question in every single meeting. And I wrote an article where, in a very, very simple way, I described the difference between machine learning, deep learning, and AI. This article is published on Docs, is pretty high level. There are some technical references. You can find it at aka.ms, deep learning versus machine learning. So machine learning is really a portfolio. You have to think a portfolio of algorithms. When I say algorithms, I mean mathematical functions that use your data to learn. That's why this is the moment where we say they are training, they are becoming intelligent, and they give you results. Most of the time, these results are predictions of the future. Then AI, I really see AI as a way of consuming machine learning. So usually you have applications, you have systems that are running on top of machine learning models, and again, they give you results, predictions, and so it's really a way of having intelligent applications that are running on your machine learning models. And then we have deep learning. We saw the amazing presentation by David before, and deep learning, you have to think about it as just a type of machine learning. It's very, very interesting because deep learning doesn't look at the linear relationship between your data points, your variables, your features, but is a way of what we call neural networks to somehow is able to train itself. So again, there are so many different types of deep learning methods, such as convolutional neural networks, recurrent neural networks, but they are all part of machine learning. So after that, I had this long meeting with them. I also created a sort of comparison between traditional programming and machine learning because my customers most of them were like software engineers. So I say, okay, you have to think about the traditional programming, which is a static logic. So you start with data, algorithm, and then you go through a computation process and you get an output. So with machine learning, we have something similar. We have data that we call features. If you come from statistics, economics, you call these also variables. And then you have output, and this is called labels, especially in a supervised learning. And so you tell your algorithm, okay, this is the input, and you have to learn that this input is actually this output. So this is done during the training. And then you get the algorithm that is the best part. You go through this, again, computation process, and the algorithm is going to then learn, and in the testing or validation phase is actually going to do the output part by itself. That's why we say very often these are intelligence algorithms. But the other question that the customers were keeping asking me, okay, Francesca, thank you very much. We understand that you got our business problem. You you explain us what is machine learning, deep learning, artificial intelligence. But when can I really understand machine learning is the right tool for me? And most importantly, how can I pick the right machine learning algorithm? So again, I say, so let's start from your business problem, because every time I sit with my data science team, with the customers, I always say, okay, you know, AI, machine learning, deep learning are very, very cool and fancy terms, but if you don't have a business problem and if you don't have data, you're not going to do, like machine learning is not possible. So I sit with them, and again, we went through a scoping phase, and I start asking them what were the business, the operation processes that they wanted to improve. And again, this was, remember, an inventory optimization problem, so they thought that time series forecasting, specifically sales forecasting, was a good starting point to optimize their product in the store, so their inventory. So the business question was, what are the forecast sales quantities per item per store for the next 4 weeks? And after we define these business questions, we started looking at the different algorithms in machine learning. Machine learning is divided in 2 big categories: supervised learning, that I mentioned also in my previous slide, and unsupervised learning. There are many, many different types of algorithms, but these are the most important, the more general ones. So the regression, if you want to answer question, how much, how many sales I'm going to have next week, for example, like our customers, this is the best approach. Classification, for example, which class does it belong to? Is it a cat or is it a dog? Clustering, we're going to the unsupervised learning. Clustering is, are there different groups? Which does it belong to? This is very good for customers understanding. Like you have a bunch of different customers and you try to use a few features to actually grouping these customers and try to offer them the best offer. Anomaly detection, is it weird or not? This is a very, very common use cases for predictive maintenance. So when you want also to predict if a machine is going to fail in the future. Recommendation, finally, I think we are all users of recommendation system. Every time that you use an app or you go to a website, you always notice that they are recommending you some products. So this is an approach that is very good when you want to answer questions such as which option should I use? Of course, with our customer, we pick the regression because we are in a time series forecasting scenario. And we started looking at the different phases because I told them we have to understand what is our journey, what is our machine learning journey. We have to prepare the data for sure, and you have to make sure that you have the right data. You have to train your model, test your model, and finally deploy your model. So we started with the data preparation, and this is something that is a part that honestly I love the most, because it's really a part where you start looking at the data, exploring the data, and you start to build additional features. It is called the feature engineering on top of your data. Most of the time, I really recommend you to do this with the business experts, data experts, because sometimes, data scientists, they are far from the business. Very nice, I can see you all now. And we started working together, and we focused our process on 3 different steps. So the first one, of course, we wanted to make sure that we had enough data, and we could validate the fact that we had enough data. Remember, we were in a time series forecasting problem, so we look at historical sales data, and we noticed that our customers was collecting weekly data per store and per product. So we were, okay, how many years do you have? Our customer had about 5 years of data, which was okay, pretty good for weekly data. If you are in a IoT scenario where you collecting, for example, sensor data every second, you can eventually look also at a different historical period. Sometimes even having like a few months of that data is going to be good. But for this scenario, we were able to find good enough data. Then we wanted to gather external data. External data usually are economic indicators, weather data, safety data. So these are all additional data that you can include in your model to see if they can affect your model in a positive way, of course, so that you can eventually get a much more accurate model. Finally, we add the future dates to the data set to get prediction. So in time series forecasting, we have something that is called horizon. So it means that, of course, this is something that you define with your customers. For example, our customers wanted to forecast the next week, but for the next 4 weeks. So our horizon was equal to 4. And in order to do this, of course, into the machine learning model, one of the input is also the weeks. So future weeks for future weeks, so that we know that the model is going to predict sales for the next 4 weeks. So let's have a quick look at the data. So we were able to find a store ID, item ID, and then time and quantities of the different items sold. Then we were able to validate these, and then we were also able to pre-process our data and make sure that there were no missing data or outlier. Then in terms of external data, we decided to use RDPI, that is real disposable personal income. So this is a very nice economic indicator because it's going to summarize the consumer power. So how much a person and a household is going to be able to purchase in the future. So very often when you are in a sales forecasting scenario, this is one of the most common external economic indicator that you want to include in your model. And then we start with the feature engineering. So for the feature engineering part, we did a few things. So we created additional time features. So this is a very, very cool part because basically you take your timestamps column and you start building additional features. So creating additional features, additional variables on top of your time column. So for example, is it which year is it? Which month is it? Is it a week or what is the week of the month. In terms of season, for example, and holiday, it is a New Year, is a Labor Day, is a Black Friday or Christmas. You have to understand that all these holidays can affect the sales over the year. And then 4-year terms, these are very cool friends if you are data scientists, because they help you with capturing seasonality. So they are very good at somehow summarize the up and down in your trend of sales. And so if you have to get that additional information in your model, you can do that by using 4-year terms or 4-year features. And then finally, lag feature. These are values at prior timestamps. So as you can see, we started just with a few columns, but we actually ended up having a much richer, a much larger data set. So let me show you now how we did this in Visual Studio Code. So Visual Studio Code, we use actually C# to do this. We created our app that is called Data App. We wanted an app that was easy to build and also that was helpful for consuming the final machine learning model. So in this app, as you can see, we have this function that is get process data for score. And here, this function, what it does, basically, he allows you to load the forecasting data, and then you are going to filter this forecasting data by IDs, and this is needed for prediction, both for sales ID, so product ID, and also store ID. And then we, as you remember, we also add the 4 weeks for prediction, because we want to predict the next week, but for sales for next week, but for the next 4 weeks. So after this, let me show you. We also use another function in, again, in C# that was able to actually, let me open this again, was able to create the timestamp feature. So here, if you scroll down, you have, as you can see, create a lag feature. This is, again, time at prior timestamps. And then, if you scroll down, you can see that we also create our 4-year features. And finally, these are all the 4-year features. And finally, we created the time features. And this is, as you can see, I just want to show you what I was showing to you on the slide. There is a year, month, week of the month, week of the year, and then there is Black Friday or is not Black Friday, is a US Labor Day, is Christmas Day or no, is New Year's or no. So I want just to give you also a snapshot of the final data set. So as you can see, the final data set that we created was this big, and so here we had much more columns. So we started again with just a few columns, and now we added all these additional variables and features. Our target variable was the value. So here is sales, it's just sales. So we perform what we call as data scientists normalization or standardization. Normalization is really just to make sure that the algorithm is running, and so that you can improve the performance of your algorithm, but without missing any relationship between the variables. So basically the scale of our values, of our sales, was reduced, was normalized. So as a second step, as you can see, we start to think about machine learning, because we were like, okay, we are fine, we collected data, we use Visual Studio Code, C# to do all the data preprocessing, the feature engineering, but now let's talk about machine learning. How can we make sure that we really are able to use this data and all these additional features that we created to train a model? So as a second step, we start to look into different machine learning tools on Azure. As you know, there is a Notebooks VM, there is the Designer right now, and we were really trying to understand what was the best tool for us. And we ended up using Azure Machine Learning Designer. Because, as we are going to see very soon during our demo, it's a tool that allows all different people in the team to see a hand-to-hand machine learning solution. So really the hand-to-hand machine learning flow is going to be clear in front of you. In Machine Learning Designer, there are of course many different algorithms that you can use. We created this algorithm cheat sheet. So you, again, as you can see, you always have to start with a question. So this is a business question. You have to understand what I want to do next. Do I want to predict between several categories? Do you want to extract information from a specific text? Do you want to find unusual occurrences? And based on what you want to do, based on the different data also that you have, you can pick a specific algorithm. Azure Machine Learning Designer is part of Azure Machine Learning Service, and just to give you an overview of what you can do, I'm going just to introduce also Azure Machine Learning Service, where there are different type of authoring tool. You have the automated machine learning, you have the designer, you have also notebooks, VMs. These are really notebooks that you can use in case you want to code and build a hand-to-hand machine learning solution in Python, in R. So you want really to customize your machine learning models. And then in terms of assets, you have data sets, experiments, machine learning workflow pipelines, models, and deployment. And then also in terms of management, you have different compute targets, different data stores where you can ingest the data and read the data and then start building your machine learning models. And then the workspace. The workspace is really a place where data scientists can share their different experiments, and also they can monitor their machine learning models over time. So for the testing and then the deployment part, we use Azure Machine Learning Designer. So let me give you an overview of what this is for. So if you go to our docs, this is our technical documentation, and if you search for Azure Machine Learning, you're going to find a lot of different options, like how you can get started with Azure Machine Learning, how you can use the Python SDK for Azure Machine Learning, how you can use the different machine learning pipelines. So here, if you scroll down, you can see that there is an experiment using a drag and drop designer. So this is exactly what we call the designer. That is part of the Azure Machine Learning package. So if you go to AIML30.azure.com, you can see that this is our machine learning portal. I'm sure that you have been seeing many announcements this week about this machine learning portal. I honestly find it very, very helpful as a data scientist, because I can go there and based on the different data science scenarios, I can pick the tool that I think is more appropriate for that specific use case. So under authoring, you have notebooks. And again, notebooks is a way just to use your own notebooks on Azure. These are Jupyter notebooks. And then you have AutoML, and you have also the designer, which is the one that we are going to use for this demo. And then if you look at assets, you can see that you have data sets, and also in terms of manage, you have a compute, data store, data labeling. So for the data sets, we use our customer sales data set, historical sales for about 4 years. But if you want, you can just click on create a data set. And as you can see here, you have a different type of options, such as from local files, from data store, from web file, from open data sets. So open data set is also very, very helpful, because as you remember, when I was thinking in terms of how I can make my data set richer, larger, I was talking about external data. And a way that you can consume this open data set, you are going to find, for example, weather data, you are going to find safety data, and also different type of economic indicators that eventually you can use for your own models. In this case, I had already a data store that was my customer data stores, and the historical data that I had was forecasting data 11.1, because my customers wanted to give me all the historical data that they had. So in Designer, you can go back to Home, and then here you can click on Designer. Another nice thing that I want to show you is that here there are many samples that show you, for example, how to build a regression. If you remember regression, I show you is very good if you want to answer a question like how many, how much, or if you wanted to, for example, predict a car price. So these are all examples that you can use to get started with Designer. If you already know what you want to do, if you already know how to build a first experiment, you can just click on plus. And what you're going to see here immediately, this tool designer is going to tell you that you have to select a compute target. Again, your compute target can be local, can be Azure, but you just needed to define it here. And then in terms of operations, what you can do. So we already saw a little bit data sets together. Here there are my data sets, but again, if you want just to get started, you can use samples data sets that are public data sets that you can use to just get started and explore a little bit more how Designer works. And then you have a data transformation, which is also very important if you need to add column, add rows, etc., convert to CSV. For example, if you wanted to get your model back to your local machine, you can split the data. So again, a lot of options in terms of data transformation. Then let's get into the most beautiful part of machine learning, which is the model training. At least I think so. So this is you have three different options, which is train clustering model, train model, and tune model hyperparameters. So you have to think about these three options as a way to improve your models, to make your models better. And also there are actually two different customized options. These, as you can see, there is a Python language. So here, create a Python model and execute a Python script. And then there is also R, execute R script. So these modules allows you to write your own code in the case that you want to use just a little bit of Designer and then you want to just write your own code, your own machine learning models in Python and in R. You can do this using these two options if you have a team, a data scientist team that is more, for example, comfortable with R. You have also other options in terms of text analytics, recommendation. As you remember on the cheat sheet, there were many different options. As you can see, let me show you. So you can just start with the data set. So in my case, I knew that my customer gave me this data set. And then if you scroll down, actually, let's close this first. And then let's say that I want to do some data transformation. So as you remember here, let's say that I want to select just a specific number of columns from my dataset. As you can see, I can just connect these two, and then it immediately tells me, okay, you have now to select the column. So you can click on Edit Column, and here, what it's going to do is going to show you what are the different columns. Like, for example, let's just do it by name. Of course, I did all that feature engineering, that data preparation, so I want to add all my features. The only feature that in time series forecasting you don't have to include is time. Actually, is at the beginning of my, yes. Because time, so you can remove it. Time is not a feature in time series forecasting, is the index. Basically is that column that is going to maintain the structure of your machine learning data set. So you don't want to use that as an input. But if you remember, we still use time to build additional features that then we use in our model. So I can save it, for example. And then the next thing that I want to do in machine learning is I want to split my data set. So this is very nice because you can also use the search box. And let's say that I want to split my data. As you know, in machine learning, we have what we call the training and the testing. I was mentioning these terms during my presentation. So usually when you get a historical data set, you always have to think about training and testing. So the training part is the group of data that you're going to use to feed your model and to allow your model to learn on historical data. But then you're going to have also some test data that you're going to use to test that machine learning model and make sure that it's performing well. So that's why we call it training and testing. So here it's very nice, this module, because what you can do is just clicking, you can say, okay, this is going to give me 50% of training and 50% of testing. Usually I prefer to train my model 70% and 30% using testing, but again, it's up to you. I don't want a randomized split because I'm in a time series forecasting scenario. So as you remember, time is very important. So I'm not going to, I'm going to uncheck that. And after that I'm done with this, we start with the most important part, which is the machine learning part. So remember, it's a regression problem. We want to predict how many products are going to be sold in the next week for the next 4 weeks. So you can use many different algorithms. So in this case, I'm using the Boosted Decision Tree because we knew that it's performing pretty well. So I just need to move it. Let me make this a little bit smaller. Okay, yes, I was able here. And then here, what you need to do, you need to select also the training part. So you can find these. If you look at training, the model, and then here, you can just leave it here, and then you're going to connect your split data set on the training model here, and then also you have to look for your testing part. So this is something that you can look at it again here, test. And here you can also look at how to test your model. So again, this is something that you can also, you have to connect. So let me make it this actually a little bit smaller, and then this, and then you can connect these to the different parts. So again, it's a very easy because you just need to drag and drop your modules. And for this specific scenario, after that you have completed your experiment, you can just click on run, and this is going to run as an experiment. So just because we don't have too much time, let me show you the final experiment. So as you can see here, we have the forecasting. Actually, let me make it a little bit bigger for you. So we have the forecasting data set, and then you can select the columns, you split the data. Here we were using a Boosted Decision Tree, and then we were training it. As you remember, in my previous experiment, I was using also the training part, and then we were scoring it. The scoring part is really where you just test your model, and you can use what we call evaluation module that is going to evaluate your model. What is nice of Designer is that besides giving you this information on the right, you can also immediately look at the documentation. So let's say that you have some questions about a specific module, like the evaluation or the edit metadata. You can just click on the link, and this, actually, let me show you. And this is going to give you the technical documentation that is going to explain you what that module is doing, so you can also understand if this is the right module for you. So, so let's go back to my training experiment. So as you can see, I started with the data set, I split the data, I train a model, and then I score it, and then I prepare this for the final output. So this is the model that is actually giving me the results using the training data set. For this part, then, after that you run it, as you can see, you have two options here. You have the create inference pipeline and update inference pipeline in case this model is already deployed. So this is really the moment in which your model needs to be pushed into production, meaning that you save it, so you have to create a predictive experiment. So in Designer, this is very easy to do because you just need to click on this, and this is going to create another experiment that is very similar to your training experiment, but has two additional modules that I'm going to show you now. So as you can see, there is a web service input, and at the end, there is a web service output. So again, instead of training, we are now at the inferencing time. So you run your predictive experiment, and then you just need to click on deploy, and this experiment is going to be deployed. And the cool thing of the Designer is that the deployment experience is very, very nice in the sense that you can look at endpoints. And here you're going to find a lot of information that actually are going to be helpful if you want to consume your machine learning model from another system, or from another application. So let's see here what we get. So we get the details. Of course, here is a bunch of details for your machine learning experiment, and then test. You can test it directly on the platform, on the Azure platform. And then you have a consumer. So consume probably is the most important part in a real-world data science scenario, because you have three samples, the C#. Here, as you can see, you can just understand how you can consume this model using C#. You have also Python here, and then also R, in case you want to consume your model using R. And then two additional information that are very important are the primary key and the REST endpoint, because these are the two information that are going to allow you to consume your model from an application. So, for example, if I go back to Visual Studio Code, if you remember, this is my data application app. So I have app config. Here I just put the primary key, cut and paste, and then in programs, here, as you can see, if I scroll down, I put my endpoint, my URI. So this is again a way just to consume the machine learning model. So let's test it out now. .NET run. So here, let's see if based on these two, this is all going to actually to give me the sales result. Yes, I want to predict. And again, as you can see, I'm going to predict here, these are the results. This data preparation app was preparing the data, but is using the machine learning model that we build in Designer. And of course, I need, as I said, the two information, primary key and the URI, just to call this model in Visual Studio Code. And as you can see, the results are weekly. For 4 weeks, and I have the number of sales for that specific store ID and for that specific product ID that I need. So this is just to show you that to do machine learning, you don't really need to code the entire time. Designer is a great tool if you have a team that is ready to do machine learning but doesn't want to code too much. And so we saw how you can use Designer and Visual Studio Code for the machine learning journey. So from data preparation, training your model, testing your model, and then your model deployment operationalization part. Before leaving you, I just want to share with you a few resources that I have been using during this presentation. So beside the aka.ms/AIML30 docs, so here is where you're going to find all the technical documentation for this session. We have also the Azure ML service, Azure ML Designer, and then the article that is comparing deep learning versus machine learning and AI, and then finally the algorithm cheat sheet in case you want to understand better what you can do with machine learning. Also in terms of what you can learn. There are some additional certification and learning paths that you can take on Learn. And it's very nice because you can, again, get certified by just completing those learning paths if you want to learn more about also data science and machine learning. Here again, these are all the resources for our session. And in terms of certifications, here there is the data science certification and the AI engineer certification. So if you want to become a data scientist, or if you just want to learn more about data science and machine learning, you can learn it there. And finally, I also want to tell you that after this session, where we learn how to build an hand-to-hand machine learning solution with Designer Visual Studio Code, there are other two sessions. One is the AIML30, and then there is the AIML50. So if you want to keep learning and complete this developer guide to AI, please stay in this room and you're going to just to learn even more. Thank you very much.